In this video we'll be looking at factorizing the difference of perfect squares, or DOPs for short. And this is the rule over here. We have a squared minus b squared can be rewritten as a plus b in a bracket and followed by or multiplied by a minus b. So this is the little rule that we will use. Right, so if I had this expression over here and I wanted to factorize it, I can do a couple of things first. I know that x squared is a perfect square, but I also know that 25 can be rewritten as 5 squared. So that's what I will do. So I'll have x squared minus 5 squared, because I know 25 is 5 times 5. So following on from our previous rule, we have x in one bracket and x in the other bracket. I have a plus and I have a minus, and therefore I must have a 5 there and a 5 there. So we have now factorized a perfect square. But if we wanted to, we could actually multiply these brackets out and make sure that we ended up with this over here. So let's do that. X by x gives me x squared. X by negative 5 gives me minus 5x. Positive 5 multiplied by x gives me positive 5x. And 5 multiplied by negative 5 gives me negative 25. And I know that and that will cancel each other out, because plus 5x minus 5x gives me 0. Therefore my answer is going to be x squared minus 25. And is that the same as that? Yes, it is. So I have factorized it correctly over here. Alright, well, I've got two more here for you to practice on. Put the video on pause and come back when you're ready. Right, well, how did you go? Well, 9x squared can actually be rewritten as 3x squared, and 49 can be rewritten as 7 squared. So my two brackets are going to look something like this. I'm going to have a 3x in there, and a 3x in there, and I'm going to have a plus 7 in there, and a minus 7 over there. And that is correctly factorized. But if I wanted to, I could quickly just do some multiplication. I could expand these two brackets just to make sure that I end up with this value, just to make sure that I've in fact got it correct. So I'm going to do that. So 3x multiplied by 3x is going to give me 9x squared. 3x multiplied by negative 7 is negative 21x. 7 multiplied by 3 is plus 21x. And 7 multiplied by negative 7 is negative 49. I know that cancels with that, so my answer has to be 9x squared minus 49. Those two agree, so I factorized it correctly. Alright, how'd you go on this one over here? Well, once again, rewriting it, I would have 4 in a bracket squared, because I know 4 4s are 16, so that will give me that value there, minus, and I know that 2 can also be written, or 4 rather, can be written as 2y squared. Alright, so one bracket, second bracket, I have a 4 over here, 4 over here, I have a plus and a minus, and I have a 2y there and a 2y there. And I factorized that correctly. But just to make sure, I'm going to multiply my brackets out. So 4 multiplied by 4 is 16, 4 multiplied by minus 2 is minus 8y, 2 multiplied by 4 is going to be plus 8y, and 2 multiplied by negative 2 is going to be negative 4y squared. That cancels with that. Therefore my answer is 16 minus 4y squared. Are they the same? Yes, they are. Done correctly. Right, finally, just a little bit more of a tricky equation to factorize. There is a perfect square in there. See if you can figure out something with those two over there. Something has to happen, and then you'll be able to factorize it. Put the video on pause, come back when you're ready. Alright, well, firstly I'm going to rewrite this as 2 multiplied by a multiplied by a, and 32 I'm going to multiply as 2 multiplied by 16. Now I know 16 actually can be rewritten as 4 times 4. Alrighty, so I know that this over here is going to be a perfect square. So let me rewrite it in this format. I'm going to take my common factor out, and it's going to be a squared minus, and 16 I can have in the bracket. I can now rewrite it as this, 2a squared minus 4 squared, because 16 in fact can be written as 4 squared. The next step is simply 2, and then I have my two brackets. I have an a in that bracket, an a in that bracket, a plus over there, a minus in that one, a 4 over there, and a 4 over there. And therefore I have correctly factorized that. Once again, I can check that this is in fact correctly factorized by multiplying 2 by this first bracket, and then multiplying that resultant bracket by this bracket over here. Sounds complicated, but let me show you what I'm going to do. So 2 multiplied by a equals 2a, 2 multiplied by 4 gives me 8, and it's plus 8, so that's in the first bracket, multiplied by a minus 4 in the second bracket. And once again, just going to multiply the brackets out as we normally do. So 2 multiplied by a is 2a squared, minus 8a, plus 8a, minus 32, because 8 times 4 is negative 32. That cancels with that. Therefore, I have 2a squared minus 32. Does this and this agree? Yes, they do. So I have correctly factorized. Alright, give this one a go. There's a little trick over here, so see if you can figure this one out. Come back when you're ready. Alright, how did we go? Well, this is how we're going to do it. We're going to leave our first bracket exactly where it is. So x plus 1 squared stays where it is. And I know that 9 is 3 squared. So I'm going to go minus 3 squared. Alright, the next step is that we're going to have our two brackets. And we're going to have x plus 1 in the first bracket and x plus 1 in the second bracket. So this over here and this over here are both in the same place. And then minus 3 squared, I'm going to put a negative 3 in, sorry, positive 3 in that bracket and a negative 3 in that bracket. Because 3 multiplied by 3 is going to give me 9, a positive multiplied by a negative is going to give me my negative. And then what we need to do is we need to simplify our little brackets. So we need to collect some like terms that are in our brackets. So this is going to be x plus 4, and this is going to be x minus 2. And we have simplified. Okay, well that's all there is really to factorizing the difference of two perfect squares, or DOPs.